Hello, today I'm gonna talk about chapter 2, motion in one dimension. And you already know how to describe a position, I believe, but just in case. So one-dimensional space means you can either have an x-axis or y-axis, right? And then of course you need the origin horizontal and the vertical, right? But if the position is at the right side of the origin, x is positive, left side negative, up positive, down negative, right? It's very simple. And then for this course, you will see three different type of graphs. The first one is a position versus a time. And the second one is a velocity versus a time. And the third one is a acceleration versus a time. You will see these three graphs for this chapter. Okay, this is one, right? So then whenever you see a graph, you make sure you check the axis name to see if this is a x versus a time one, or velocity versus time, or acceleration versus time graph, right? So make sure which graph you talk about, you work with. Okay, always make sure. And then you can either have a graph or you can have this type of diagram like this, right? So these two are basically identical, right? Because y when t equals 0, your position is 0, right? And then when t equals 1 minute, your position is somewhere, around 50 here, right? When your position is time is 2 meter, 2 minutes, your position is about 100, something like that, right? You can do this way. And of course, so this is again the same thing in terms of a table, right? So it's a time, your position is given here, right? And then slope. So again, so think about in the general, one-dimensional, graph you have. This is you in general, you have a y-axis. This is your x-axis, and assuming you have a linear function, so this is our code, this is y equal mx plus b. Okay, so then m is your slope, right? How do you find your slope in one-dimensional space, two-dimensional space, and graph here, right? So your slope is what? Delta y over delta x, right? But our physics graph here, we use x for our y-axis, and then we use the time for our x-axis. So if you have a linear function in this xt graph, your slope here is going to be delta x, which is instead of delta y here, and then instead of delta x, we use the t-axis, so slope is delta x, right? But what is this? Delta x over delta t, that's your velocity, right? So in other words, in xt graph, your slope is a velocity. So then you see, you can also convert your velocity, the xt graph to vt graph. Why? For the first 3 minutes, what happened? So this is your slope, and this is your velocity for 0 to 3 minutes. And then the next line here is your velocity from 3 minutes to 6 minutes. And then your final velocity again changed from 6 minutes to 9 minutes. So for example, first 3 minutes, your velocity is what? The slope of this line, which is about 1, right? 3 minutes, you have a 180, right? So your velocity is about 1 meter per second. So here unit is minute, this is a second, so that means that this is a 180 seconds, right? Instead of 3 minutes. So that means your, x-axis is time, t-axis is 180 seconds, and then you move the 180 meters. So your velocity is roughly 1 meter. And the second slope is a slope and the last steeper because you're moving, during the given 30 minutes, you travel less distance. So then if you calculate the height change, you see your velocity is about zero point 0.4. And then during the last, 30 minutes, you have a steeper line whose velocities are faster. So then if you find the slope, you will see the slope here, corresponding to this line is about 1.6 or meter per second or something like that, right? So make sure you always can convert xt graph to vt graph, right? So now you can pause your videos and then solve the question. So here, so for the, first second, so this is the when times 1 second, 2 second, 3 second, 4 second, 5 second, and 6 second, right? So you're looking for the graph for VT graph, right? So you see, you have to make sure always check the axis name carefully. So for the first 3 seconds, what happened? You travel with a constant velocity. And the next 3 seconds, you travel with a constant velocity as well, but you travel longer distance. So your velocity is faster. So the answer is A. Why? Because you have this is for the first 3 seconds, and then you move up fast. Sorry, so this I thought, this is a xt, right? If it's an x, the answer is A. But this is a velocity graph, right? So for the first 3 seconds, you move slower than the next 3 seconds. Sorry, the answer is C, right? And then now the similar question. You have a motion diagram, car moving along a straight line, but it's moving to the left, right? So now you're moving to the left for the first 3 seconds, slower, and then another 3 seconds, you're moving faster. But the thing is, you're moving to the left, so the sign of velocity is negative, right? So the first 3 seconds, slower, and the next one is faster, but negative signs. So the answer is yes, T, right? And then you also now you have another graph, but make sure this is a xt graph, right? It's not vt graph. This is a position versus time. So for the first few seconds, what happened? Your position here is constant. What does that mean? You're not moving, right? So that means here your v is a 0. You can also find the slope of the first line. What is the slope of this line? 0, right? So your velocity for the first period is a 0, right? And the second period you're moving, but the slope here is what? Negative. So your velocity is a negative value, right? But the slope is a constant. You have one slope from here to here. So that means your velocity is negative, but constant. So the answer is C. Example, you have a graph gives the position versus time. Again, you have a position versus time graph, right? So draw the car's velocity versus time graph. I recommend you to pause the video and then do it by yourself. And then let's talk about one by one. So now let's draw the VT graph here, right? For the first 2 seconds, what happened? Your slope for the first 2 seconds is -2 here, right? And then next 2 seconds, your slope is 0. And then the last one, you move horizontally by 2 seconds, but vertically, how many units you move? From -4 to 6, you basically move 10 units. So the velocity here, or the slope, is 10 over 2 is 5. So now you have a -2, 0, and 5. So your velocity graph is -2, 0, and 5. Okay? I recommend you to carefully review this, examples by yourself. And the question number 2 here is to describe the car's motion in words. So now what happened? You start from origin, right? This is your location when t equal 0, right? And then for the first 2 seconds, what happened? You move to the left, right? From here to here, right? With the velocity -2. And then what happened to the next 2 seconds? You don't move, you stays there for 2 seconds. And now you start moving to the right for 2 seconds with a faster speed, 5 meters per second, from -4 to 6. That's the answer for question B. Okay. So now you can also change your graph from velocity to position graph. So now, assuming you have a VT graph, but now you want to convert this graph to XT graph. For the first 15 seconds, what happened? Your velocity is moving 1 meter per second. So that means, what is the physical meaning of velocity? You travel 1 meter per second. That's what 1 meter per second means, right? So you travel 15 meters for the first 50 seconds. So then that's why you start from origin, and then for 50 seconds, you travel 15 meters. In other words, the slope of this line is 1, which corresponds to this velocity line, right? And then for the next 5 seconds, what happened? You travel with a -3 meters per second. So then total distance you travel will be another 15 meters, right? Which is 5 times 3. But now, because your velocity is negative, so you're moving to the left side. So that's why you come back to your original location for the next 3 seconds. Okay. Another question here. You have a motion diagram, car moving along a straight line. That's a graph, motion diagram you already saw from, previous question. But now we are looking for the position versus time graph, right? So then initially your position is 0 here, right? So what is your initial position? It's some negative x position, right? So then your starting point must be here, right? Or here. So these 3 can be your candidate for the answer, right? And then for the first 3 seconds, you move slower to the right. And the next 3 seconds, you move faster to the right as well. So which one has a steeper, slope for the, next to 3 seconds? So the answer is yes, E, right? Why? You start from negative position and then less steeper and more, right? And the same thing, you have a now VT graph, right? So for the first few seconds, your V value is some positive value. And then next time you have a V equals 0 here. So that means you're at rest. Your position doesn't change. So then what happened? You should have a positive slope, right? For the first few seconds. So that gives you this or this, right? And then after this time, your velocity is 0, that means you're not moving anymore. So the answer is yes, D. Okay. Another example, which velocity versus time graph goes with the position graph. So now, this is again xt graph. For the first few seconds, your slope is what? Constant. And slope is positive, right? So then you have to have a positive and constant velocity, which is here, right? And then later what happened? Your slope, which is tangent for the curve, is getting less and less. At one point here, your slope is a 0, so your velocity is decreasing to 0. So the answer is a C, right? So next section is about the uniform motion. Uniform motion is nothing but moving in a straight line in which equal displacement occur during any successive equal time interval. So it's called uniform constant velocity motion. So that means that that's just a straight line, right? So in other words, if you have a straight line, that's about the constant or uniform velocity motion, right? Of course, your velocity is again, in general, that's for the normal y and x graph, right? Your slope is what? Delta y over delta x, right? This is your slope. But for physics, we use a special, axis name. Your y-axis is x, your x-axis is time. So we change the slope, which is a delta x over delta t, which is your velocity, right? And from this, if you modify, so assuming this is the delta t, and then if you multiply delta t both sides from here, what happened? Left side you have a Vx times delta t, right side is a xf minus xi. So then your final position, if you move this one, and then is what? X initial plus Vx times delta t, right? So then now, here's the position graph of an object. Again, at t equal 1.5 seconds. So right here, right, t is 1.5 second. The object's velocity. How can you find the object's velocity? This is nothing but the slope at this point. So which is the slope of this line, right? So your change time is 1 second. Vertical change is 20 seconds. So your velocity is 20 meter per second. So your answer is B. Right? And another example, train is moving due west at a constant speed. A passenger noted that it takes 10 minutes to travel 12 kilometers. And then how long will it take the train to travel 60 kilometers? So it's moving to the left, right? So basically your velocity is negative, right? And then travels 10 meters, 12 kilometers. So what is your velocity? Your velocity is, of course, and then how long will it take the train to travel 60 kilometers, right? So you have a delta x is 12, right? So then what is your time? So basically, because this one travels 10 meters for 12 kilometer, your velocity is what? 12 kilometer over 10 minutes, right? So it means it was 1.2 kilometer per minute, right? So in other words, it will take 1 minute to travel 1.2 kilometer, right? So in order to travel 60 kilometer, how many times distance you have to travel? 5 times. So it will take 5 more times, which is 50 minutes, right? And another thing, important property of a VT graph is the area under the VT graph. The area under the VT graph is a displacement. Why? Because distance travel, delta x, this displacement is what? Simply, what is the definition of a displacement? How much distance you travel? That's the velocity times time, right? So the velocity here is the width of this square. And then, I'm sorry, width of the square is delta t. The height of this square is b. So the area of this square rectangular is delta x times v, which is displacement, right? So in other words, the area under the VT graph is your displacement. Again, you have a VT graph, area under the graph is your displacement, right? So the object when t equals 0, position was 0, right? When t equals 4, right here, what is the object position? So you have to find the displacement, right? So then you simply find the area of this, the rectangle and then triangle, right? So the rectangle area is 2 times 4 is 8. The area of the triangle is a half of it. So the total displacement is 12. Mm. And instantaneous velocity, so far we talk about, xt graph is a straight line. So that means your velocity, which is slope of this line, is always a constant. But what if your xt graph is not straight line like the curve here? Then your velocity at each time is simply the tangent of the curve. That is called instantaneous velocity. So for example, instantaneous velocity here is the tangent. Okay? So then, here you haven't learned the calculus, so you don't need to actually calculate the value, but you need the concept. If you have xt graph that is curved, in order to find the velocity at this moment, you have to find the tangent of the angle, right? And then if you have a, VT graph, which is not a, square or rectangular, but instead you have a V graph curve, but again, still the area under the VT graph is your displacement. So a slope at a point of a position versus time graph of an object is what? Yep, that's exactly what I just talked about, right? It's the velocity, right? So now, when do object 1 and 2 have the same velocity in xt graph? What does that mean? When do they have the same slope? For example, object number 2 has a straight line. So that means that this is a constant velocity motion. But object 1 has a different slope or tangent. Here, the tangent is here. Here, the tangent is here. So here, tangent is here. Here, the tangent is this one. So that means the velocity, which is a slope or tangent of a curved line, is changing. So in other words, motion 1 is not a constant velocity motion. So the discussion is simply when curve 1 has a tangent or slope, the same as slope B. So that's this line. So this is somewhere here. So the answer is A, at some instant before time t0, right? Right here, the curve 1 has a tangent line whose slope is the same as this line. And then similar question, you have two motions, P and Q, along P line, along Q line. So again, P line is a constant velocity motion. And the Q, of course, it depends on which slope you have, right? And then when do they have the same velocity? Of course, Q has a varying velocity, but find the position where whose tangent line is the same as the slope of a P, which is somewhere here, right? So that means right this moment, motion 2 has a velocity is identical to the Q, right? So the answer is similar question. A car moves along a straight line. The following graph shows the car's position as a function of time, right? Displacement is 0. When? Of course, here, right? And then here, y, displacement is x, right? When do you have a speed 0? When the slope is 0, so b and e, your slope is 0, right? Speed is increasing. When do you have an increasing speed? So that means that now think about here. Slope at A position, what happened? This is your slope, which is velocity, right? And then sometime later, your slope is getting less steeper. Here, less steeper, and then getting zero, right? So at A, what happened? Speed is decreasing. But here, what happened? Slope getting steeper and steeper. So the speed is increasing at point C. This question is not simple, so make sure you understand, pause the video and think about it again. Okay, that's it. And I'm gonna talk about, acceleration next time. And then make sure your homework is due, soon. So, and then, I have some student who asked me about, how to find, homework. But, as indicate in the syllabus, you must buy your textbook. Okay. So that's, I think the cost is not bad because it's a 9.99 per month. Okay, so make sure you have to read your textbook by yourself. Again, I cannot cover all topics in the textbook. Okay, and then problem, the homework said is about from your problem section, not the question sections. Okay, be careful. At the end of each chapter, you have two sections. The first one is a question with a multiple choice question, and then the second section is a called problem. And your homework problem is from the problem section. Okay, and let me know if you have any question.